Look around you right now. The building you're sitting in, the car parked outside, the bridge you drove over this morning, the fork you used at breakfast, the phone in your pocket. All of it begins with the same thing: iron ore pulled out of the ground, and a process so extreme it sounds like science fiction. Steel is the most produced material in human history. Every single year, we make over 1.9 billion tons of it. That is more than all other metals combined, multiplied by 20. But turning raw rock from a mine in Australia into the beam holding up a 100-floor skyscraper in New York, that process is one of the most spectacular industrial achievements on the planet. Today, we go inside the steel mill and follow the journey from ore to sky. Humans have been working with iron for over 3,000 years, but iron on its own is a problem. Pure iron is actually quite soft and brittle, not ideal for building empires. The ancient secret? Add a tiny amount of carbon, somewhere between 0.2 and 2%, and iron transforms into something extraordinary, harder, stronger, more flexible. That material is steel. Early steelmakers in India, China, and Persia discovered this accidentally, forging legendary blades, the famous Damascus steel swords, that baffled European soldiers for centuries. Nobody in the West could understand how these blades held an edge so perfectly. But producing steel in large quantities was nearly impossible for most of history. It was slow, expensive, and inconsistent. A blacksmith might spend days producing a few kilograms of decent steel. That changed in 1856, when a British engineer named Henry Bessemer invented a converter that could turn 30 tons of molten iron into steel in just 20 minutes. The world had never seen anything like it. Steel became cheap. Cities began reaching for the sky. Trains crossed continents. Ships got bigger. The Industrial Revolution wasn't really powered by steam. It was built from steel. And today, the process Henry Bessemer started has become something almost unimaginably powerful. Step 1. You need iron ore. The world's largest iron ore deposits are in Australia, Brazil, and China. Vast open-pit mines that are visible from space. These mines run 24 hours a day, 365 days a year, with trucks the size of houses hauling millions of tons of reddish-brown rock out of the earth. The ore is crushed, screened, and processed to increase the iron content. Low-grade ore might contain only 30% iron, not enough for an efficient furnace, so it's processed into pellets or sinter, concentrated, consistent balls of iron-rich material that a blast furnace can work with efficiently. You also need Step 2. The blast furnace. This is where the transformation happens, and it is one of the most impressive structures in industrial engineering. A blast furnace stands 30 to 60 meters tall, as high as a 20-story building, and operates continuously for years without ever being switched off. Turning it off and back on again is so expensive and complex that once lit, it runs until its lining wears out, sometimes for a decade or more. Iron ore pellets, coke, and limestone are loaded into the top. At the bottom, jets of air heated to over 1,000 degrees Celsius are blasted in through pipes called tuyeres. Inside, a chain of chemical reactions begins. The coke burns, releasing carbon monoxide gas. That gas rises through the furnace and strips. Step 3. Turning pig iron into steel. There is a problem with pig iron. It contains about 4% carbon, far too much. That makes it hard but extremely brittle. Drop it, and it shatters. Steel needs carbon content below 2%, usually far less than that, to have the right balance of strength and flexibility. The modern solution is the basic oxygen furnace, the BOF. The molten pig iron is poured into a giant vessel, and a lance is lowered in and blasts pure oxygen at supersonic speed into the liquid metal. This oxygen reacts with the excess carbon, burning it away as carbon dioxide. The temperature jumps to 1,700 degrees Celsius. The whole process takes just 40 minutes. 40 minutes to convert 300 tons of molten pig iron into steel. There's also a second method, the electric arc furnace, or EAF, skips the blast furnace entirely. Instead of starting with ore, it melts down. Step 4. Shaping it into something the world can use. Liquid steel is poured into a continuous casting machine. A towering structure where the molten metal flows in from the top is shaped by a mold and emerges from the bottom as a solid rectangular slab, still glowing red hot. moving on rollers at several meters per minute. These slabs are then sent to a rolling mill, a series of massive rollers that squeeze and stretch the steel into the desired shape. Flat sheets for car bodies and appliances, I-beams and H-beams for building frames and bridges, rebar, the ribbed bars inside every concrete structure you've ever walked on, wire rods for cables, pipes for oil and gas. At every step, the chemical composition is tested. Alloy elements are added to achieve specific properties. Chromium and nickel for stainless steel, manganese for strength, vanadium for high temperature performance. What began as iron ore in the ground is now the frame of a skyscraper, the body of a car, and the spine. Before we finish, 5 facts about steel that you probably didn't know. Fact 1. The Eiffel Tower was considered a temporary eyesore when it was built in 1889. It was scheduled to be demolished after 20 years. The only reason it survived was because it doubled as a radio antenna. Today, it receives 7 million visitors a year. It is made almost entirely of iron, technically puddled iron, and requires repainting with 60 tons of paint every 7 years to prevent rust. Fact 2. Steel is the most recycled material on Earth. Around 690 million tons of scrap steel are recycled every year. Recycling steel uses only 26% of the energy needed to make new steel from ore. Fact 3. The steel industry accounts for approximately 7 to 9% of all global carbon dioxide emissions. More than aviation, more than shipping. The race to make green, hydrogen-powered steel is one of the biggest industrial challenges of the century. Fact 4. The Burj Khalifa, the world's tallest building, contains approximately 55,000 tons of steel rebar inside its concrete structure. That steel was produced across multiple countries and shipped to Dubai, a global supply chain to build a single tower. Iron ore, coke, limestone, air. 4 ingredients that have given humanity skyscrapers, trains, ships, surgical tools, and the entire modern-built world. Every city on Earth is held together by a metal that was discovered by ancient blacksmiths and perfected in a 19th century factory in Sheffield, England. Steel isn't just a material, it is the skeleton of human civilization. Every week on this channel, we open the case on another object, another material, another invention that quietly holds the world together. If you want to keep discovering the extraordinary stories behind ordinary things, subscribe and we'll see you in the next file, The Object File.